Hello, Professor. My name is Akanksha, and today I'm going to explain my assignment 5 for CS 5 and 2. We are learning about how many computers in our system can keep track of what's happening at the same time. This is really tricky because they all work separately, but there's a special trick. It's called Shandy Lamport algorithm. It helps us take a snapshot of all the computers, like a picture, to see what each one is doing at the same moment. So now let's come into our assignment. The first one is consistent and inconsistent states. Let's first understand what we mean by consistent and inconsistent. Let me give an example. Like, think of two kids passing a ball, and one kid says, I passed the ball, and the other kid says he hasn't received it yet. So, this is a bit confusing. It is like out of order. Computers are the same way. Like, we look at their steps, like uh, two states, like a P1 step and P2 step, and if they are consistent, and if they are like, why are they consistent? Let's say S00, it says yes, and it's a starting point. No messages sent or received. And coming to S10, uh, P1 local state is 1, and P2 local state is 0. And also it is consistent means yes, it is consistent. And also P1 moved one step and there are no messages sent. And coming to the next global state, which is S uh, 220. Here you can see, and P1 P1 local state is 2, and P2 local state is 0, and it is consistent. In the reason is like P1 moved two steps, and P2 is 0 because it is still waiting, and that is okay. And coming to the next state, which is S11, and P1 local state is 1, and P2 local state is also 1, and it is also consistent. And here the reason is like both P1 and P2 did one step, and like everything is fine, like nothing is out of order. And also next, coming to the next state, S21, and P1 local state is 2 and P2 local state is 1. And if it is consistent, yes, it is consistent. And the reason is P1 did two steps and P2 did one. All are in correct order. And coming here is coming to the next thing is S01 is the bad one because it says that P2 got a message before P1, even before it sent it. That's like um getting a letter in the mail without nobody writing it. So this is it about consistent and inconsistent state. Next, coming to the valid transition sequence. Now let's now look at how the system moves forward, like step by step, which is in a correct way. So now let's start. We start at S00, where both computers are at initial state, which means they haven't done anything. Then comes to the then P1 does one step. Um, Now we are at S10, and now P2 does one step. So here we are at like S11 after S10, and then P1 does one more step, and we are at S21. So now we have a path S00, S10, S11, and S21. And here every step is like consistent, and here we can see one computer moves and then the other one, like there is no jumping or no skipping of this. And no one receives before the message is sent. It means when the message is sent, then they will receive it. Next, coming to the third one, which is property. So here we see P1 has reached state 2. Now we check a special condition called um, this one, this attribute. This attribute means has like just a question, like has computer P1 done step 2? So like that. Now let's check where this happens. So in S20, so in S20, we see yes, P1 has done two steps. In S21, yes, like again, P1 has done two steps. So this attribute can be true. It might not happen right away, but that can happen later. This means that if P1 keeps running, and it does not stop, it will finally reach step 2. So here, yes, this attribute is like true. It can become true even if it is not true now. Like it can happen true later on. And so this is it about this attribute, property attribute. And coming to the next thing, monitor evaluation. So now let's talk about monitor. So uh, let me give something like, think of a monitor, like think it is a teacher who watches the computer, what the computer is doing. So let's say the monitor wants to check if the property attribute is true. So what it says is like, it checks is like, did P reach state 2? So there are two ways the monitor can decide. If so Yeah. So if at least one path leads to the property attribute being true, then that attribute is possibly true. And the second condition is, if every possible path that leads to the property being true, then the property is true. So either ways, if property attribute is true, then it's possibly true. So here, um, like each states, so like the monitor needs to be smart, and it has to look at real possible situations. As here you can see, inconsistent states could lead to enormous assumptions before they are transmitted. Next, coming to the lattice diagram. So this lattice diagram is showing all the global states and the transitions. Now, this diagram, um, it is like a map. So it shows all the states like S00, S11, S10, S20, and S11, so on. So it shows like how the states and how the system moves from one state to another state. So each circle is like a state. As here you can see, each circle is a state, and these lines are the transitions. So now, these lines between shows like take steps, like this is transition. So this line shows S00 is transiting from S00 to S11. So this is the valid path. So valid paths follow proper order, like S00 goes to S10, and then to S11, and then to S21. So it's like this, from here to here, here to here, and here to here. So this diagram also shows which states are not allowed, and like S01, where the order is broken. As here you can see, it is shown as inconsistent state. So this is about lattice diagram, and this diagram also helps us see the big picture, like seeing the entire playground, and you can see which kid is standing at which position, and you can monitor their movement too. So conclusion, to sum up, that Chandy Lamport algorithm helps us like take a full picture of what every computer is doing. So what every state is doing, and what like what transitions taking place, and everything. So we use a lattice diagram to show computers moving from one state to another, and a monitor watches and checks if something, like the property attribute has happened, and it only uses the valid states or not. So this is what I understood about what happening in the distributed system uh, at when each computer is running at different times. So this is it. Thank you.